Reduction of alkynes. Generally, reduction of alkynes are two types. Here we are using two different reagents. This is alkyne reduction with hydrogen. Two different types of reducing agents we are using. One is palladium barium sulfate, and trace amount of phenol we have to add it. Trace amount of phenol because of phenol to reduce the poisonous of palladium. So that we are using that phenol as a trace amount. Then one more is sodium or lithium in liquid ammonia. So whenever we are using that palladium barium sulfate with phenol, this is we are calling as a Lindar's catalyst. Lindar's catalyst or Lindar's reduction. So whenever we are using sodium or lithium in liquid ammonia, this is a Birch reduction. So here, whenever we are using that sodium barium sulfate, then it form here C double bond C or C double bond C or with H. This is we are calling as a cis-alkenes. So whenever we are using the sodium in liquid ammonia, it form trans-alkenes. So here this is a trans-alkene. So first case we are using that Lindar's catalyst is cis-alkene. Another case it is a trans-alkene. Sometimes they ask me a question. They will give this is an open chain compound. Very easy to understand that whether it is a cis or trans. But here, for example, H2, the same case. Here we don't very easy to cis and trans because it is an open chain compound. CH3, H. This is a cis-2-butene. Then another one is CH3. Then CH3, H. This is a trans-2-butene. Cis-2-butene, trans-2-butene. But whereas other case, if you are taking the cyclic system, it is very difficult to understand that whether which one is a cis, which one is a trans. That the simple trick is whenever it is react with the hydrogen in the presence of palladium barium sulfate, then small amount of or a trace amount of phenol. This is we are calling as a Birch reduction. Sorry, Lindar's catalyst. Then phenol. So one more is sodium or lithium in liquid ammonia. This is a Birch reduction. So in this case, if it is whenever they will give the cyclic system, you should write down both are thick line or both are dotted line. Double bond. If both are hydrogens are dotted line, or both the hydrogens are thick line. This is we are calling as a cis isomer. If it is one is a thick line, another one is a dotted line. So here hydrogen, then thick line. This is one more hydrogen. Or the top one is thick line, hydrogen, then dotted line. This is we are calling as a trans isomer. Whenever we are using these two reagents, it form always these two we are calling as a geometrical isomers. Thank you.